In Lesson 5, we're going to be learning how we can divide with fractions without using a model. In order to do that, we are going to start with a review of a division problem with a model. So the first problem here says Ryan has completed 6 hours of his training course. This is 2/5 of the total amount of time of the course. How many total hours is the course? So this is one of those problems where it's telling us a whole number is a fraction. So when we have problems that say a whole number is a fraction of the total, that means we're taking the whole number and dividing it by that fraction. With our model, notice it's already kind of started for us. We would draw the 2/5 and show that that 2/5 is also 6. Okay, so this means that the 6 is being split up over 2 sections. So 6 divided by 2 is 3, meaning 3 in each of those sections to get the total of the whole bar, or 3 times 5 equals 15. So 15 would be the total hours of the course. Some things you may have kind of caught on to at some point. If you notice, here's our fraction. 6 is being divided by the numerator, and then our answer to that is being multiplied by the denominator. This kind of works into the algorithm that we use to divide fractions. You can always, of course, use a model if you find that to work for you. And we are going to today use the algorithm and then check it by using our common denominator method. So the first thing that we need to know with our algorithm is that we're going to use something called the reciprocal. The reciprocal is the inverse of a fraction, or the opposite. When you multiply a number by its reciprocal, you always get 1. So basically the idea behind a reciprocal, and I'm just going to use this fraction here that we had from the previous page to show what a reciprocal is. 2/5 is the original fraction. Its reciprocal is the inverse, or the opposite, meaning I'm just going to flip around my numerator and denominator. So 2/5 reciprocal is actually 5/2. And the idea behind it is if you take a fraction and its reciprocal and you multiply them together, you get 1. So to check if it's right, I'm going to multiply these two. 2 times 5 is 10, and 5 times 2 is 10. 10/10 is the same thing as 1. But the easy method to finding the reciprocal is just to flip your numerator and your denominator. So to divide fractions, you can multiply by the reciprocal. So we are going to see what this looks like. We had the division problem 6 divided by 2/5. I'm going to take the 6 and put it over 1. Anytime you're dividing with a whole number and you're looking with fractions, you're going to turn the whole number into a fraction by putting it over 1. And then I'm going to write divided by 2/5. So I always recommend writing the problem out first so you don't make any errors. We are going to take the 6/1, instead of dividing it by 2/5, we're actually going to multiply it by the reciprocal of 2/5. So what I like to do is I like to box this in to show that that's going to change. The 6/1 stays the same. I'm going to change my division into multiplication. So I'm taking my dividing and changing it into multiplying. And then I'm going to multiply by the reciprocal of 2/5. So by 5/2. Okay, and then just a reminder to multiply fractions. You just multiply your numerators together and your denominators together. So 6 times 5 is 30. 1 times 2 is 2. To simplify this, I can read this as 30 divided by 2, or I can divide both of them by 2, either way, to get 15/1, which is the same thing as 15. Now I'm going to show you another shortcut method too, and this only works when you're multiplying with fractions, and this is called cross simplifying. So I'm going to go back to this step right here of the problem, I've already changed the division to multiplication. With cross-simplifying, and again, it doesn't matter if you do it this way or if you cross-simplify. Cross-simplifying is a method of simplifying before you multiply instead of multiplying and then simplifying. So to cross-simplify, you're looking at the numbers that are diagonal from each other in your fraction pair here. So I would be looking at the 1 and the 5 together, and then the 6 and the 2 together. And what I'm trying to do is see if they have a common factor, or in other words, if there's a number that they can both be divided by. So besides 1. So 1 and 5 can only be divided by 1, so those two are good to go. But if I look at the 6 and the 2, they can both be divided by 2. So what I can do is actually cross these off, and I really recommend crossing them off so you don't get confused. And you divide those numbers by the 2. So 6 divided by 2 is 3, and 2 divided by 2 is 1. Now I'm going to go ahead and multiply across numerator and denominator using these different numbers, the new numbers. So I'm going to do 3 times 5, which is 15, and 1 times 1, which is 1. So notice I still get the same answer. So you can either multiply originally and then simplify, or you can cross-simplify, which should give you a simplified answer most of the time. All right, we're going to check our answer with common denominators since we know this is a method that works. So we had 6 over 1 divided by 2 over 5. Common denominator, anytime you have 1 as a denominator, the common denominator that you can use is the other one. So I'm going to turn 6 over 1 into fifths by multiplying both my numerator and my denominator by 5 and getting 30 fifths. I'm going to rewrite the problem, replacing the 6 over 1 with the 30 over 5. When dividing with common denominators, remember the denominators give you 1. 5 divided by 5 is 1, so I can just cancel that out. And I'm going to put my first numerator, 30, over my second numerator, 2. And then I have to simplify it. So I can either do 30 divided by 2, which is 15, or I can do the same method I did over here where I divided both by 2. So no matter which way we did this, we ended up with 15, including with the model as well. All right, let's look at another example. Okay, so example 2, there was 2/3 of a pizza left. 6 people at the party wanted to evenly split the leftovers. So we have 2/3 of a pizza, and you'll see that's already shaded for us. Here's our 2/3. And we're splitting it up evenly amongst 6 people. So with the model method, remember this is where we would split this way into our 6 equal parts. And then we're going to find how much is shaded for each one of those. So each one has 2 parts shaded in it out of the 1, 2, 3 times 1, 2, 3, 4, 5, 6, or 3 times 6, which is 18. 2 18ths can be simplified, dividing both by 2, which is 1/9. Okay, so that should be just a review. We're also going to see how we can multiply by the reciprocal. So the original problem was 2/3 divided by 6, which I'm going to change into 6 over 1. Instead of dividing by 6 over 1, I'm going to be multiplying by its reciprocal. So the 2/3 stays the same. The division changes into multiplication, and I find the reciprocal by flipping the numerator and denominator of the second fraction. I'm going to go ahead and cross-simplify here because I see that I can. 3 and 1 are good to go. Their only common factor is 1, but 2 and 6 can both be divided by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. I'm going to multiply 1 times 1, which is 1, and 3 times 3, which is 9. Notice this got me my simplified answer right away. I'm going to prove this one more try with common denominators. So 2/3 divided by 6 over 1. Again, when you have a denominator of 1, use your other denominator as your common denominator. So I'm going to turn this into thirds. 1 times 3 is 3. 6 times 3 is 18. I'll rewrite the problem. with the 18 thirds instead of the 6 over 1. When we're dividing with common denominators, the denominators cancel each other out because they give us 1. And then I put my first numerator, 2, over my second numerator, 18, and simplify. Both can be divided by 2, which gets us that 1/9 we were looking for. So you can now choose which method you would like to divide with.